Hi everyone, how are you? So welcome back to Code Type Management. In our last video, we looked at form login. So which is stateful and uses sessions, right? But what if you are building an API that doesn't use browsers, cookies, or sessions? So what if you need something purely stateless? So in the last lecture for the form login, we know that is totally stateful. Now we are going to know about the stateless authentication. So when the stateless authentication or stateless authentication mechanism came into picture, so then we start about the basic authentication. Okay. So it is one of the simplest and oldest authentication mechanism on the internet. But let me warn you right now, while it is incredibly easy to set up in Spring Boot, using it incorrectly in a real world production system is a massive security risk. Okay. So today we are doing a complete deep dive into basic authentication, and we will explore the internal Spring security filter chain, decode the authorization header to see exactly how your passwords are sent, and then I will show you some code blocks, how to implement it, and finally I will show you some major disadvantages of basic auth and why modern microservices uses JWT. Okay. So first of all, what is the basic authentication or the stateless authentication and the base 64 myth? So unlike form login, basic authentication is completely stateless. This means the server has no memory and it does not create any HTTP session, and it does not give you a JSession ID cookie. In the last lecture, I have told that in the form login, it has some memory and it also creates the HTTP session and it also gives you the JSession ID cookie. And from that cookie, it will check the credentials and match. And here we came to know that it is stateless. And why it is stateless? As it has no memory. It does not create an HTTP session and it does not give you a JSession ID cookie. So because the server has no memory, the client must provide who they are on every single request. So they do this by sending an HTTP header that looks like this. How? Like this basic some something basic, after that some base 64 value. So critical warning is that this base 64 is not encryption. So a lot of junior developers look at the string and think, oh, my password is encrypted. But no, it is not. So that is base 64 encoding. So if anyone will decode that, then anyone will get the password. So it is just a different way of writing the text. So anyone can decode this BMLTY something, this value in 1 second to reveal the actual user and the password. So this is actually the text is Nimai 12345, which is encoded in base 64 format. So it provides zero cryptographic security and can be decoded by anyone. Therefore, basic authentication must strictly be used over HTTPS or TLS, which encrypts the entire transport layer. Next, why use headers and the filter chain instead of request bodies? So instead of request bodies, why we are sending in headers? So that is a very good question and very important question. Why not just send the username and password in a JSON payload? So when the request hits your Spring Boot server, what happens internally? The flow is very similar to form login, but the entry point is different. But before that, I will tell you, why do we send this in a header? Why not just put the username and password in a JSON request body? First, because GET requests don't have bodies. You need a standard way to authenticate across GET, POST, PUT, delete every methods. Second point is servers often log the request bodies and query parameters for debugging. So if your password is in the body, then it ends up in the server logs. And headers are rarely logged, keeping your credentials safer. Okay, so these points I have covered, like HTTP standard compliance, support for all HTTP methods, and security and logging. Like here, get and delete requests generally do not have the request bodies. Using a header ensures credentials can be sent regardless of the HTTP verb. And security logging, that I have also discussed. Like web servers and load balancers frequently log request URLs and JSON bodies for debugging. Standard security practices dictate that authorization headers are omitted from logs, reducing the risk of accidental credential exposure. Next, internal Spring security flow. So when this request hits your Spring Boot server, what happens internally? The flow is very similar to form login, but the entry point is different. So first, security filter chain is the entry point. After that, basic authentication filter. In case of form login, that was different. So through the basic authentication filter, it intercepts the request, extracts the authorization header, and decodes the base64 string into username and password. Next, the thing is similar, the authentication manager and the DAO authentication provider. So in the basic authentication filter also, base64 decodes the string back to the username password. And next, it comes under authentication manager, which passes it to the DAO authentication provider. So that these two, like authentication manager and DAO authentication provider, coordinates the validation. After that, the user details service. So the provider fetches the user via the user details service. Next, the password encoder. So it hashes the incoming decoded password and compares it to the stored hash. So if successful, then an authentication object is placed into the security context for the duration of that single request. And once the response is sent, the context is totally cleared. No, nothing will be cached, nothing will be stored. So that's why it is stateless. Next, how to configure it in the Spring Boot 3. So let's write the code like this. In modern Spring Boot security, it enables the basic auth incredibly simple. So we just configure our security filter chain. So you can see the configuration annotation, enable web security annotation, public class security config. Then we are creating our bin security filter chain, which may throw the exceptions. So here we are disabling the CSRF because basic auth uses no session cookies. So by default here we are disabling this is CSRF disable. You can see here. Then authorize HTTP request auth any request authenticated after authentication, like enable like here HTTP basic authentication through the http basic, then customizer dot with default. So that format, this boilerplate code will be available in any you can take it from any websites or any GitHub repo like that. Here the main point is why disable CSRF. So notice that we explicitly disabled the CSRF protection, like cross-site request forgery relies on the browser automatically attaching session cookies. But Basic Auth doesn't use any session cookies. So CSRF by default rely on the browser automatically attaching the session cookies, but Basic Auth doesn't use the session cookies, CSRF is not a threat here. So that's why we are disabling it. And because basic auth is stateless and does not utilize cookies, CSRF protection is generally unnecessary for pure basic auth APIs. Now, the massive disadvantages. So, first one is credential exposure. So, your actual password, even if encrypted via HTTPS, is transmitted across the network on every single API call. Like in the header, it will be there. So if any hacker will able to track your code base and they will enable the log for the headers, then your credentials will be available for them. Then terrible scalability, like performance killer, because it is stateless. Spring Security must execute a database query and perform an expensive cryptographic hash like bcrypt on the password for every single request. So this causes massive CPU and database overhead when under heavy load. No logout mechanism, because there is no session on the server, you cannot truly log out. The client browser simply caches the header. Now, no token revocation. If credentials leak, you cannot revoke a token. The user must physically change their password in the database. So these are the main problems. So that's why to solve the problem, JWT actually came into picture, which I will discuss in the next lecture. So the difference, like the basic auth versus JWT, the difference are, first of all, stateless. So basic auth is stateless, JWT is also stateless. Credential exposure high, like every request, is low, like only during login time. DB lookup required for every request. It is optional, usually only at login. Token expiry, there is no token expiry, no token concept is there. But JWT here, yes. Now revocation capability, there is no revocation capability like that I told, like the user must physically need to change their password. But JWT, yes, via blacklisting. So use the basic authentication for quick internal tools, development environments to check the connectivity and all your credentials are working fine or not, like this, and simple testing APIs. But for modern microservices, public APIs, mobile backends, always utilize JWT or OAuth 2. Okay. Now, some interview questions I will also discuss, like why is basic authentication considered stateless? So, because like the server doesn't store an HTTP session or user state, and the client must provide full credentials with every request. Okay. Now, is base64 secure? No, it is the reversible encoding format, not an encryption algorithm. Base64 is basically for encoding, not encryption. Why is CSRF protection usually disabled when using basic auth? So CSRF attacks rely on the browser automatically attaching the session cookies, which basic auth doesn't use. Okay. So can you implement a true logout feature in basic auth? No, since there is no server-side session to destroy, the only way to log out is for the client to close their browser or clear their cached credentials. Okay. So from the server side, there is no option to destroy. From the client side, they can do that by closing the browser or clearing the cached credentials. So these are the basic authentication concepts. If you want to know any other things, then you can comment below. Okay. And I hope this masterclass helped you to understand the stateless authentication. So just hit the like button, subscribe the code tab management, and get ready for our next deep dive into JWT. So see you there. Thank you, everyone.